Hello everyone, welcome to our webinar. I'm Soheila and I'm here with my colleagues Rick and Christian. With the holidays coming up, it's the perfect time to explore the drinks we enjoy, both alcoholic and non-alcoholic, and learn why they feel the way they do. We will talk about viscosity, which is how thick or thin a liquid is, and we will measure it using our MicroVisc Pro. The MicroVisc Pro is a fast, precise, and easy to use instrument for measuring viscosity. It works well with small samples, gives accurate results in minutes, and can measure a wide range of beverages from soft drinks and juices to beers and alcoholic drinks. It's perfect for quality control and product development. By the end of this webinar, you will understand why viscosity matters, see the differences between Guinness alcoholic and non-alcoholic drinks, and maybe even impress your friends or family at holiday gatherings with your new knowledge. Let's get started and celebrate the season with some fun science.
Thanks, Soha.
Yeah, you're welcome.
Thank you, Soha. Wonderful. Right. So yeah, I think at this point, let's get to the science, huh, Christian?
Sure, yeah,
What are we doing?
So we're going to be measuring the viscosity of a couple of beers we have here. One one of them is non-alcoholic, the other one is,
No, this is not.
so this is non-alcoholic, other way around. This is the alcoholic one, and they are both of the Guinness brand. So let's get started. I'm going to open the MicroVisc Pro cover. So this is the MicroVisc Pro, which we'll be using to measure the viscosity of the beer samples continuously. So if we go here, we can see you have the option to measure your viscosity automatically. So you load your sample, you place it on the MicroVisc Pro, tap the automatic button, and it measures the viscosity right away. So it selects the shear rate for you, and you get the viscosity measurements very quickly. We also have a fixed rate mode if you're interested in measuring your viscosity at a fixed shear rate. So for example, 6,000 inverse seconds or whatnot. And this is great if you want to control those velocities very well. So let's go ahead and select that fixed rate mode. And also I'd like to explain that this here is our microfluidic channel in which we will be measuring the viscosity. So how we do that is we have a pipette where we load the sample. So it's think of it as a syringe holding your sample. We load that sample, place it on the chip, and then we start a run, and it's going to give us the viscosity measurements right away. So I'll go ahead and start loading the first sample. Do you have a preference over non-alcoholic or alcoholic?
Let's start with the non-alcoholic.
Sure.
Do that one.
Let's do that.
It's still early in the morning.
So let me go ahead and load that sample. Okay. Don't push out any bubble there. Okay. So there's the sample loaded. And then what I'm going to do is remove any sample from the outside of the pipette. And then I'll be pushing out to get the sample to the very top. Excellent. So here we have our sample loaded into the pipettes. And now I'm going to go ahead and place this on the MicroVisc Pro. So let me go ahead and push that a bit.
So another cool thing about the MicroVisc Pro is that it has temperature regulation. And so you could set temperatures anywhere from 4 to 70 C. So if you are interested in seeing how temperature impacts viscosity, you could easily do that with a MicroVisc.
Thank you, Rick. So here I set the flow rate, fixed flow rate. I will set 5 segments at a temperature of 15 degrees, which is clearly below room temperature. So it could be the temperature at which you're drinking the beer after you take it out of the fridge or after the bartender gives it to you. So I'm going to go ahead and continue with the starting. And there's also additional information here, like the shear rate range for this chip, which should be good for all the beer samples. You also have information for the viscosity, shear rate range, and other technical info you may be interested in. So here it's prompting us to enter the sample name. We'll enter beer, and I think this is non-alcoholic.
Non-alcoholic.
So put no alcohol, ALC.
And if your sample has a barcode, we have a barcode reader here. So you could easily just scan your sample and the name pops up.
Exactly. So I've already entered the name, and you can see it's a very easy to use touchscreen. Kind of reminds me of my smartphone touchscreen.
Yeah, so within just a couple of minutes, you're actually beginning your viscosity testing. So our technology is very user-friendly, simple to use, but yet you're still getting really, really accurate data.
So we can see now the plunger is engaged with the pipette, which has the sample. And what's going to happen now, it's going to wait for a little bit to stabilize the temperature. Yeah, if you think it's better, we can get the camera a bit closer to see the screen.
So while we're doing that, we could show you some cool features of how you could see the data. So you can look at it as a function of in a graph form. You could also see how the temperature regulation is going. Here it's LTA controlled, and so it's a very stable system. And as you know, viscosity and temperature go hand in hand. And we've built into the functionality of the instrument that a measurement cannot be taken or initiated until the temperature is held for 2 minutes, and viscosity does not change more than 0.007 degrees C. So in automatic mode, the software will run through a number of priming steps to understand what the sample viscosity is. And so that's what's going on now.
Correct. It's filling up that channel. Like Rick said, it's gauging what the viscosity is to before it pushes for the first measurement. Excellent. So we can see here it's the first viscosity measurement. The graph you see here on the left is viscosity versus time. So it's going to push the sample through, measure the viscosity, and it's going to be plotted here. So you'll see now it's going on to the next segment already. We can see the viscosity is very steady, nice and flat. So it's measuring the steady shear viscosity of your sample. So it's already done with 2 segments. It's going on to the third at this fixed rate that we input at 15 degrees Celsius. So we can see here again the data showing. We see a little tiny bubble that passes the channel, but that's okay. The bubbles will be pushed to the channel, and you can still get good data. Nice. And then if we go here, we can see this chip has 3 sensors, which are measuring this pressure drop in the channel as you're pushing the sample through. So we can see here on the right this characteristic linear pressure drop that's occurring in the channel. It looks like it's already done with the 5 segments. And then here, if we go to this one, we can see our table with all the results. So we can see the viscosity measured for this sample was around 1.5, and it's pretty consistent for all the segments. And as you know, it's 15 degrees, the temperature, and the shear rate is fixed at 8,000. And again, if you still have sample left, which we do, you can measure at a different temperature or a different velocity. it's up to you how you want to vary these conditions. Also, we have here an R-squared value on the right, and we can see that the R-squared is a gauge of the quality of your data. So the higher the R-squared, the higher the quality of your data is. So this R-squared is pretty much the fit of this linear pressure drop of your data. So the one that I showed you here, this pressure drop along the channel, and it fits that. It takes the R-squared, and that's giving you the quality of your. It's an indicator of the quality of your data. So.
Okay, I'll move back the camera.
Wonderful.
So what's
So-
next?
What's
What
next?
was the average viscosity for non-alcoholic?
Average was about 1.5
Okay.
centipoint for this non-alcoholic one.
Okay.
And we would like to compare the
Yeah.
viscosity with the alcoholic
Yep.
one.
And we are going to have a taste test.
Oh,
Yeah.
okay.
That's always the best part.
Yeah.
Wonderful. So let's go ahead and disengage the plunger so that we can load our next sample through. So I'll take another pipette. And this time we'll load
Alcoholic.
perfect.
A really nice feature of the Microdisc Pro is that you don't have to clean in between samples if the samples are missable. So it saves a lot of time, makes your measurements very fast as well.
Wonderful. Okay. Go ahead.
So while Christian is loading that, I'm going to grab the beer from the fridge for our taste test.
Wonderful. So go ahead and load the next sample. There we go. So here it is. And then I'll go ahead and place that. And then we're going to run at the same condition we ran before. So 15 degrees Celsius and the same shear viscosity, shear rate. So have a very good one-to-one comparison between the two beer samples. So I'll name this one. So I'll call this one beer. Start. So my colleague, Sohaila here is preparing the cups for the taste testing that we decided to do. Oh, I see you have the beer samples there.
I'm always the most popular person in the office. I know where the beer is kept. All right. How's the data looking?
It's stabilizing the temperature right now.
Okay.
So it's going to wait another 30 seconds just to ensure that the temperature, of the sample we just loaded is homogeneous and we can get the best viscosity results for that.
So some things that we look at when we're doing viscosity testing is, how are the subtle differences between similar formulations? Like, for example, the Guinness beers that we have, one is alcoholic and one is non-alcoholic, and how does that impact viscosity? How does viscosity impact, the experience of drinking the beer? Is there a relationship with viscosity and, how it drinks, drinkability? And so for maybe manufacturers, is your goal to try to make the experience as close to an alcoholic beer? You can use viscosity to help dial in your formulation to understand, the viscosity is slightly different. So maybe that's where you could begin to adjust your formulation. And viscosity is a very easy way to see how formulations are either more similar or more different.
Mm-hmm.
So it looks like it's priming right now. So you notice that we introduced the next sample without cleaning the channel. So we didn't forget anything. So what we're doing is we're running sample after sample continuously or continually. So we're running the next sample after the previous one with no cleaning required in between. So what's happening is we're simply pushing the sample through the chip and introducing the new one. And this is possible because we have this microfluidics, and it's very easy to displace the previous sample and start, measuring the viscosity of your next one.
Yeah, we're dealing with very small volumes, microliter scale. So if you're dealing, let's say you have a very precious sample, you're not having to use a lot of samples in order to get very high quality measurements.
Exactly. So here we have the viscosity being measured. So it's nice and flat, steady, shear viscosity. So let's see what the next segment looks like. So I think this is the third or fourth segment. And then we can see it's already finished with about all but the last segment. And the viscosity I'm seeing right now, if you look here on the right, you can see the real-time viscosity. It's about 1.6 centipoint. So I think the non-alcoholic one was around 1.5.
1.5, yeah.
Right.
Yeah.
And if you go here to the table with your data, which you can export, so you can export this data, you can have import a USB, or you can export it to your computer directly, remotely, connect the cable or remotely. So we can see here the viscosity is 1.6, we saw. And if you look at the previous data, it's 1.5. So we can see this higher viscosity for this alcoholic beer sample. And that's more or less expected because I can think of a couple of reasons. One is you have this alcohol in your sample that's driving this viscosity higher. And it could also be due to other formulation changes that the manufacturer has implemented to each of the brands to have the best mouthfeel flavor profile for this.
And so Soha is going to do a blind taste test for us. So she's going to pour out both alcoholic and non-alcoholic beers, and Christian and I are going to taste them to see if we can detect any kind of physical differences.
I won't look.
Yeah, I'm not looking either.
So while my colleague is pouring the samples, so now you see we've measured the two samples. And at this point, you can measure additional samples, no cleaning required. Afterwards, at the end of the day, you're going home, you want to leave the instrument overnight, you can clean your sample, clean the chip. So for that, we have an automatic cleaning mode here. So what it does is you load your sample into the pipette, your cleaning solvent, that is, you load it into the pipette, you place it on the Microbus Pro, you go to that cleaning mode, and then you select from one of the low to high cleaning strength options, and then it's going to pretty much flush the entire pipette to the chip for you, pretty much cleaning the chip.
Okay. You ready?
Ready.
Ready.
Okay.
First one.
First one.
Thank you.
Looks great.
Sounds good. Oh, wow.
I'll share your experience. Still.
It tastes great. I love Guinness. I might need more. So.
You can do it after the webinar.
Oh yeah. We have to keep it professional. No, it's nice. I mean, it smells good. It looks like it's got that really nice dark
Mhm.
look, nice
Right.
and small bubbles from the nitrogen.
I mean, I'm not a viscometer, but I feel like this is lower viscosity.
It feels a little bit more thin,
Yeah,
would you say, in your
Yes.
mouth?
it does.
It doesn't have that velvet kind of
No,
experience.
exactly.
Yeah, so I'm gonna say this might be the non-alcohol.
Same. I agree with you.
Let's take the other.
Yeah, let's see. After this, I'll have a better idea.
Oh yeah, there's a big difference.
Oh, yeah.
Yeah,
Yeah.
I feel that velvetyness. The bubbles are more pronounced too.
Mm-hmm. Yes.
This is, yeah, I think this is the alcohol.
Yeah. I like this one more.
Yeah, this is great. There's more body.
Yes, that's true.
A little bit more body,
Yeah.
more,
Can I tell if the body is from the bubbles mainly or also
yeah,
the viscosity as well?
it's probably a combination of both. But
Exactly,
yeah, you
yeah.
can definitely tell there's a difference in like if you look at both, like the
Mhm.
tiny bubbles on the right are much
Yeah.
more pronounced, whereas this one there's almost no
That's right.
bubbles anymore.
That's right.
Okay, so,
I agree with
so
you.
you are correct.
Right.
Yeah.
Ah,
So
okay.
the first one was not alcoholic,
Mhm.
second drink was alcoholic.
Ah, okay. So I guess I'm like a little bit, I'm not a viscometer, but I could tell when the viscosity was higher.
Yeah, it is interesting, even though the viscosities were similar.
Uh-huh,
You know, we can detect that with
Yeah.
with the Micros Pro.
exactly,
But maybe more importantly, you could really tell the difference.
Yeah.
By the experience.
exactly. So just a small change in viscosity, right? That's
Yeah.
very well detected here with the high accuracy.
Mhm.
You can definitely distinguish between, different mouth feels,
Yeah.
textures.
No, there's definitely a difference.
I'll finish the second one.
Good job.
Yeah, the non-alcoholic one was good too. It's just, yeah, it just doesn't have the velvetyness.
No, it does
Not
not.
that very nice, smooth
Yeah.
richness. It's good, but it's not,
Yeah,
there's a big difference in
Yeah.
the whole experience, actually.
I think it needs higher viscosity, the
Maybe,
non-alcoholic one.
exactly. I mean,
Yeah.
if you could maybe make this a higher viscosity, even higher in viscosity than the original,
Yeah,
that could help to bring about that velvety.
exactly, exactly. I agree.
Mm. I need more. Sounds delicious. It's a good way to start your day. So we also have some other data that we'd like to share. We had fun with beer here. So we also did some other testings, comparing different brands, alcoholic and non-alcoholic. And so Christian's going to bring that up to show how this viscosity trend kind of holds up.
So here we have, we're sharing our screen, our PowerPoint slide. So let me move this aside. So here we have the viscosity of multiple beers. So we have the 2 Guinness beers that we tried, as well as 2 Heinekens with alcohol and without, and Corona as well. So we measured these at 4 different temperatures with the Microvis Pro instrument you see here as well. And we can see this drop in viscosity when you increase the temperature. And for all samples, the alcoholic one had displayed a higher viscosity. And you can see this change in viscosity between the samples is amplified at this lowest temperature we measured. So we can measure at 4 degrees, which we did here. And this instrument goes all the way up to 70 degrees. So we can see that this is a very powerful tool to distinguish these changes in viscosity for these samples at this wide temperature range that's relevant for different conditions that these beers are exposed to. So I think it's pretty cool to see, quantitatively with these measurements, what the differences are. And this can help with, ranking your formulations, screening multiple formulations with high throughput with this continual measurement feature, no cleaning required. So it's, I like seeing these results.
Yeah, it's a really easy instrument to use, but yet the quality of data is still extremely high.
And then here we have, perhaps you have samples that you want to characterize and you don't have an instrument, but you want to send them to us. We can characterize those for you. So we have a sample testing service. And here is a QR code you can scan to find more information related to that. And then here is our contact information if you want to contact us through the different social media platforms. And of course, we have a cute picture of the Microvis Pro there as well.
Right, so we ready for some questions? Anyone have questions out there?
Let me check the question box and see if we have questions.
Opening the question box.
So let me check.
Oh, so one of the questions I can see here from far away. I have very powerful glasses. My vision is really bad, but with these glasses I
think
can
it's
see.
better with Guinness. Right?
Maybe that's why I can see.
Yeah,
So can
happens to
you
me.
can you also measure the viscosity of wort samples? Oh, that's a interesting question. We've actually measured the viscosity of such samples before. Our colleague here, Dr. Sohaila, has actually measured these samples and released an application notes to comparing the viscosity of these multiple samples of wort that she measured. So wort is a very, for those maybe not familiar, it's this component that's produced in this beer making process, and it's a lot of folks are interested in measuring this viscosity of wort to better predict these properties of these samples and how that's going to influence the final product.
Okay, thank you, Christian. So the second question here is, what is the minimum sample required for measuring the viscosity with Microvis Pro?
Minimum sample is 100 microliters of sample. So with this, pretty much a quarter of this pipette, and loading that, you have enough to get data points.
Here I see another question. So someone is asking about different chip types that we offer. So can you just briefly explain what is the difference between?
Sure. So we have
chips?
Multiple chip types. The one we have here is the A05. This is for low viscosity samples, like these beer samples. So you can use this for many other samples, like wort samples, many liquid-based samples of low viscosity. There's also other chips for higher viscosity samples, even up to 1 million centipoid, and other chips that will allow you to get different shear rate ranges as well.
Thank you. Another good question. How do you check the accuracy of your measurement?
That's a good question. So to check the accuracy, we can look at that R-squared value in the data plot. So that's pretty much characterizing how linear is that pressure drop in the channel. And if it's very linear, if the Oxford is close to 1, you have very good quality results. Another way is to measure the viscosity of a viscosity standard and compare it against its certificate of analysis. So we do that very often here in-house. And that's something you can do every certain number of samples to ensure you're getting the best viscosity data.
And typically the percent error is less than 1%. And repeatability for a stable sample is 0.5% RST.
Exactly.
Sounds good. And we have another question. So maybe you explained during the webinar, but here the question is, how do you clean the chip with MicroVisc Pro?
Good question. So as we mentioned, you can run sample after sample without cleaning. We call this continual measurements. So this allows you to get high throughput measurements with this instrument. And then afterwards, at the end of your series, if you want to clean, run a sample through your chip, you can do that. And so you simply load the cleaning solvent into your chip. So for these samples, we would load a buffer or aqueous solvent. So you load it, and then you go to the cleaning mode, and that is going to automatically push all the sample through the channel for you. And another thing the cleaning mode does is that it has multiple stop and go cycles and soaking times as well to ensure that your chip is clean even when you have higher viscosity samples.
Thank you, Christian. I think we also have CCS for MicroVisc Pro. So if someone is interested in automatic cleaning of the chip, they can actually have CCS with their MicroVisc Pro order.
Yeah, the chip cleaning station is really nice because it also dries the chip. And so if you're worried about cross-contamination, the chip cleaning station will go through robust cleaning, and then at the end, we'll go through a drying step. And the chips themselves are very resistant to different solvents. Basically, the only thing you can't run in there is HF because of the glass components, but otherwise, yeah, alcohols, acids and bases, there's not an issue with those running it in the chip.
Yeah, thank you, Rick, for pointing this out, because here the last question was, can we run DMSO on this viscometer? So the answer is yes. As Rick explained, the only solvent that we cannot run on our instruments is HA, but you can run like 99% of the solvents with our instrument.
And it's also a closed system, which is nice if you're working with any kind of volatile samples. Because it's a closed system, you don't have to worry about volatility impacting data.
Okay.
Yeah.
Thank you both. There is no other question here, so we can end up the webinar. Thank you everyone for joining our webinar, and thank you Christian and Rich for tasting the beer and testing the beer. Tasting and testing. So thank you everyone, and have a good rest of the day.
Cheers.
Thank you.
Bye.
Coffee.